Um, you're looking at a blank template of the Unit 5 notes for stoichiometry, which is a thing that is completely new. And it takes two things you love and puts them together. And those two things are writing balanced reactions and also doing math. Everyone loves putting those things together, and we're going to do that today. So first, a little bit about what stoichiometry is, and then we'll jump in and I'll show you the two most common kinds of stoichiometry problems, the two that you would want to make sure that you knew how to do at the end of today. All right, so stoichiometry, what are we going to go with here, Blue? Sure. Stoichiometry is how you keep track of chemical quantities in reactions. No, that's two. Please, let's do better. Off on the wrong foot. There we go. Go away. All right, keeping track of chemical quantities in reactions. Again, if I'm going too fast, sound off in the chat. Oh gosh, all right, just let me know. So keeping track of chemical quantities and reactions is basically like if you start with X amount of something, how much of something else you're going to end up with. Or if you have X amount in grams of this one thing, how much of this other thing are you going to need to react with that? That is stoichiometry. It's a very powerful tool and a tool that's used very commonly in this class. In a year that's not a pandemic when we're doing labs, but we haven't done a single lab this year, of course, but you would use stoichiometry a lot. Okay, and it's based off of the mole ratios for balanced reactions. Got a balanced reaction right here that I'm going to use this one all day today with hydrogen and nitrogen reacting to make ammonia. This is one of the most common chemical processes in the United States. This ammonia is used for fertilizers, it's used for cleaning supplies, and so therefore it's like one of the most mass-produced chemicals in the United States. And the mole ratios are these numbers right here, the 3, the 1, and the 2. Sometimes we call them coefficients. See how I highlighted it with the same color? And those coefficients can mean two things. And I'm going to teach you both. But I'm going to go to this blue if that's okay. All right, so the coefficients can mean two things. On a very basic level, they can mean the number of molecules of each reactant and product. So quite literally, when this reaction happens, it takes 3 molecules of hydrogen to react with 1 molecule of nitrogen to make 2 molecules of ammonia. I'll draw a picture. Okay, you don't have to worry about what these molecules look like or anything, so don't worry about this bond. We're gonna learn how to do this next unit. Okay, there's 1 molecule of hydrogen, H2. Here's another molecule of hydrogen, H2. Here's another molecule of hydrogen, H2. They're connected by a single bond. Not important right now. And then literally reacts with 1 molecule of nitrogen. Nitrogen has a triple bond, and I would get killed in the comments if I didn't write that. You don't know what that means yet, but you will eventually. So it just has 3 lines between it, but that's not super important. It's the N2 right there. You'll learn that later. And then when they react, they rearrange themselves to make 2 ammonia molecules, and ammonia is NH3, so here's what ammonia looks like. And this is literally what is happening when you write this reaction out. When you balance it out and you use those coefficients, you're saying that 3 of these hydrogen molecules will react with 1 of these nitrogen molecules. And by react, I mean they break themselves apart, they rearrange themselves, and they make these 2 ammonia molecules. So the 3, the 1, and the 2 literally on a molecular level mean the number of molecules of each of the reactants and the products. Again, the reactants are on the left-hand side, and the products are on the right-hand side of this reaction. Okay, so that's what it means on a very basic level. But it also means, and usually more importantly for this class, is that if you expand that out, instead of looking at just molecules and expand it out, it can also mean the number of moles of each reactant and product. Okay, so number of moles would be more important, I guess, for this class, and those coefficients are sometimes called the mole ratio. Mole ratios. And instead of talking about molecules, like one single molecule, now you can talk about moles, which is a lot of molecules, right? 6.02 times 10 to the 23rd molecules or something is 1 mole. And that is where you're able to do some important math. And you're able to convert between either the products or the reactants or anything in between to make some inferences or calculations on how much of one you would need if you had another. Okay, and there's sort of two kinds of problems for them. The first one is called a mole-mole problem. And I'm going to rewrite the reaction here. Am I going too fast, by the way? Is this okay? Great feedback. I'm rewriting the reaction here. Oh, geez. This. You can still see yours. That's fine. I'm just rewriting it so you can see on this part of the notes. We're going to use this reaction all day. By all day, I mean for the next 25 minutes. And there's two kinds of problems. The first one is moles, moles. You're able to say, able to take moles of one thing and convert to moles of something else. It's a very simple process. You just use the numbers from the balanced reaction. Okay, and we did these kinds of conversion problems back first quarter, so you might hopefully remember them, but if not, I'm sure they will come back very, very quickly. In a problem like this, it reads, how many moles of NH3, that's ammonia, can be made from 11 moles of hydrogen? Okay, so in this particular problem, I'm only looking at the ammonia and hydrogen. I'm not looking at nitrogen. And there's a ratio for them, a relationship between them, in that 3 hydrogens will always give you 2 ammonias, or vice versa. Okay, and you can use that to do a very simple calculation, probably maybe even have already done it in your head because it's not a very hard calculation. But here's how it sets up with some math that we've learned in the past. We've got 11 moles of hydrogen that's given to us in the problem. Always write what you're given first. And remember writing conversions where we had, oh, I guess I was going to draw a straight line, but no. Conversions to get from one thing to another. And in this conversion right here, you put 2 things that are equal. And 2 things that are equal from our balanced reaction are the 3 moles of hydrogen and the 2 moles of ammonia. So 3 moles of hydrogen and different color for the MEMS, 2 moles of ammonia. And when you set these up, you might remember that the one you want to get to goes on top, and the one you start at goes on the bottom to cancel out. Or start with, should I say start with? Okay. So in this problem, I'm just using the numbers from the balanced reaction. I've got the one that starts on the bottom. I started at moles of hydrogen, so I'm going to put that on the bottom. That would be from the balanced reaction 3 moles of hydrogen. The 3 came from, right there where it's yellow. Look, I'm going to highlight this one yellow too. 3 moles of hydrogen, 3 moles of hydrogen. And then the next one is the one you want to get to. In this case, if you reread the problem, you want moles of ammonia, or so yeah, NH3. So you write the number there is in front is in 2 moles NH3, and you can see again, excuse me, 2 moles of NH3, 2 moles of NH3. That's where the numbers come from. Mathematically, very simple. You're just multiplying by everything on top and dividing by everything on bottom. So I'm going to just, oh, you might notice also that moles of hydrogen cancel out, right? And the only thing left is moles of ammonia. So you know you did it right. And the math is just 11 times 2 over 3. So on your calculator, maybe you already did that. If you're calculating along, which I hope that you are, you get 7. It's gross 7. I can do better. 7.33 moles of NH3. So to go back to say what this problem is really doing, you're saying that if you have 11 moles of hydrogen and you use all of that and convert all of that into ammonia, you would make 7.33 moles of ammonia. It's a powerful tool in lab because you're able to predict how much of something you would get before you even do any lab. Okay, before you do any experiment, you can actually figure out, oh, if I start with X, I'm going to get Y of something else. Very important math for this class, especially in a year that's not a pandemic when you'd actually do labs and we could come back and do labs of stoichiometry for the rest of the year. Maybe we'll get to that one point. I hope that we do, but right now, obviously, we're not going to be doing those kinds of things. Okay, questions about that at all? Easy enough setup. I'm going to have you try one. So here's the one below it. This one says, how many moles of nitrogen N2 are required to make 43 moles of NH3? Use the one that we did above as a guide. And I should say this before you jump into it. You can ask these problems all sorts of different ways. Okay, it's kind of like saying, I had, in that last problem, I had 11 eggs. How many cakes can I make? Cakes is like the end. Or I have 11 eggs. How much sugar am I going to need? Okay, so you're talking about two reactants. Or I want to make 11 cakes. How many eggs do I need? So you're asking all these different questions in like the start and the finish, but in reality, it's the exact same math every single time. All you're doing is starting at one thing and converting to another. So in a problem like this example here, how many moles of N2 are required to make 43 moles of NH3? You're literally just starting at 43 moles of NH3 and you're going to N2. And this problem does not ask about hydrogen in any way, so you don't use that number. So take a second. You probably have started, because I'm rambling on, and try to set up this problem, at the very least, set it up. And if you have a calculator, calculate it out so you can figure out what the answer is. I'll give you a minute or two. Okay, hopefully you put something down, you wrote something down to see if you could get the right answer. And I will go through it. Okay, so you start with what you're given. Sorry, I gotta get rid of this. What we're given is 43 moles of N2. And in all these problems, you're starting at one thing and just converting to a different thing. Okay, so no matter how it reads, that's what's going on. So we could go back up to our reaction here. And if I could get rid of this and this, oh no, there. In this particular problem, we're starting at, as it reads, NH3 here, and we're going to N2, so moles of N2. People don't like these problems, and even I just did a good example there. It's because you have to read this thing more than once, okay? Especially as I'm talking, I have to read it more than once. And for whatever reason, teenagers don't like to read things more than once. Are you guys familiar with that phenomenon? Okay, so get used to it because you're going to be reading things more than once on these to make sure you're starting at the right spot and ending at the right spot, especially when I make it more complicated in just a moment. Anyway, this one is fairly straightforward. As you can see, the numbers come from the balanced reaction. So 2 moles of ammonia would go, sorry, I wrote it down wrong. I'm done. You probably like, why is he doing this? There you go. This should be NH3 because I'm given that. And so on the bottom then goes 2 moles of NH3, and the number 2 came from the balanced reaction. And then on top goes the one you're going to. In this case, I'm going to nitrogen, so it's a 1 mole of nitrogen there. And as I mentioned, this one, you're not worried about hydrogen in any way. Okay, this question doesn't ask about hydrogen, so we're not talking about it. And then mathematically, very easy, just 43 times 1 over 2. Notice that these cancel out, little units do. You're left with moles of nitrogen, and so that's going to be what you want, because in the question it says how many moles of nitrogen there. And so 43 divided by 2, of course, is 21.5 moles of nitrogen. How many of you had that? Raise your hand. Do some sort of emoji to make me understand that you got that. Oh, good. Good to see some emoji. Does anyone have any questions about it before we move on? Well, this is nice. And mole is like the real important part. But in reality, if you were in lab, you wouldn't put something, you don't measure things out in moles. Instead, you usually measure them out, especially if they're solid things, in grams. And so those problems are called mass problems. And mass problems are more challenging because it's all about the mole ratio from a balanced reaction. But um, the if you're given grams, you have to convert your grams into moles, then to use the mole ratio, and then convert your answer back into grams of something else. So it involves 3 steps for mass problems, but these are the more common ones because these are the ones that you see when you're doing things in lab. Now, as you can see, I've kind of set this up. I'm going to write this out like I'm going to write the work right here, and then I'm going to show like have the steps here, and I'll color code everything. So I'm just going to, that's how I've set this up. And you can set it up however you want in your own little notebook or your head. But if you're using Notability, that's kind of what I've got going on here. Okay. And yesterday, my students liked having, like saying A is the thing you're given and B is the thing that you want. And they appreciated that. So I'm going to stick with that. And this is going to involve some things that you maybe remember again from first semester, including finding molar mass. That's why your periodic table is super useful. And then doing some conversions. Okay, so this might look familiar to you. We've done some similar things, but it has been a few months. And what has happened in between then and now? Basically nothing. It's been a pretty, uneventful year. Okay, so let's look at this problem. It says how many grams of nitrogen are required to produce 10 grams of ammonia? Notice this question is about grams, not moles. We're given grams of one thing, we want grams of something else. That's why these are called mass problems. Start with mass of one thing, end with mass of something else. But the idea is the same. Take the thing you're given and convert it to the thing that you want. So always start with what you're given, which in this case, that's not a 10. In this case is 10 grams of NH3 given to us in the problem. And in this particular problem, I'm going from, if you just were reading, I'm going from NH3 to grams of N2. Sort of like saying, I want to make 10 cakes. How many grams of sugar do I need? Same idea. Okay, but in this case, the cake is ammonia and the sugar is nitrogen. Okay, I'll stop talking. First step is to take your thing that you're given and convert it into moles. So convert, that's not how you spell convert. Grams of A into moles of A. And again, the A is the thing that we are given. To do that, you're going to want to use the periodic table, okay? And I have mine here. And our thing is ammonia NH3. So we need, maybe you might remember, to get there, convert grams of ammonia into moles of ammonia, you use the molar mass. Okay, so you have to use the periodic table and add the molar mass of ammonia. Here's my periodic table right here. And so I find nitrogen. The formula is NH3. So nitrogen is 14, and hydrogen on this side is 1. Okay, so I'm going to take, in this problem, I'm going to write it up the top here so it's out of the way. 14 for nitrogen, and then plus the 1 for hydrogen, but there are 3 of them, plus 1 times 3 for hydrogen. That equals 17 grams. So the molar mass of ammonia is 17 grams of ammonia. I got it from the periodic table. Does that ring a bell? That looks familiar to you, I hope. It's been a while, so it's understandable if you don't remember that, but that's kind of what we'll be doing for these problems. Any questions on where I get the 17 from? Good talk. Next part is the second step is the step. Oh, by the way, let's get better at this. Here we go. This is 1, and this is step 1 there. So we're all very clear. Mostly it's about my mastery of notability. The second step is actually the one that we just learned, which is to use the mole ratio from the balanced reaction. And in that, The thing you start with is going to go on bottom, and the thing you want to get to is going to go on top. So that's what it looks like. And I can highlight them here for you as you're writing. In this particular problem, the thing we're starting at is ammonia. So that's the A. That's the A. The number is 2. And the thing we're going to in this problem is nitrogen. So that's the B. That's the B. This is step 2. Might as well while I'm over here. Step 2 with a circle. Step 2 with a circle. Just so we're staying organized and you don't get mad at me. Here's what it looks like. Again, these numbers come from the balance reaction. Why are you? All right. So in the balance reaction, you can see that there are 2 moles of ammonia for every 1 mole of nitrogen. Again, it's the same thing we just learned in the previous problem. The nitrogen, the 1 is the one, see how they're all highlighted the same color. And then for ammonia to 2, that's bad. 2, that's worse. To 2, highlighted the same way there. That's second step. So now what we've done is we've converted to moles. We've used the mole ratio to get from ammonia from here to there. And if I stopped right here, my answer would be in moles, but I want my answer in grams. So the very last step is to convert your answer into grams. So convert moles of B into grams of B. Again, we're going to turn to the periodic table, but now we're not talking about ammonia, we're talking about nitrogen. And we say, that's not cool. We say 1 mole of nitrogen now on bottom, because you want it to cancel out, and then you find the molar mass of nitrogen. Okay, so we look on the periodic table. We know nitrogen is 14. It's N2 though. That's our formula we're working with, right? So we say 14 times 2 equals 28. So the molar mass of nitrogen is 28 grams of nitrogen, again, because we double, because the formula says N2. Then if you're following along, check it out. You don't always have to draw the lines, but just to show you, grams of ammonia cancels grams of ammonia, moles of ammonia cancels moles of ammonia, moles of nitrogen cancels moles of nitrogen, and what you're left with is grams of nitrogen. And if you reread the problem for the 10th time, you'll see the question says how many grams of nitrogen. So I set it up correctly, as long as all the numbers are correctly. Mathematically, all you're doing is you multiply by everything on top and you divide by everything on bottom. So I'm taking, here, watch this. I'm taking 10 times 1 times 1 times 28 divided by 17 divided by 2 divided by 1 and hit enter on my calculator. Okay, that works every single time. No need to be weird about it. If you want to have your own way of doing it, where you're doing like 10 times 1 divided by 17 times 1 divided by 2 times 28 divided by 1, guess what? It works the same exact way too. You get the same answer. Whatever works for you, don't care. And in this case, if you do all that math, you end up with an answer. I'm going to write it on the left-hand side if that's okay. No, I'll squeeze it in here for the maths. I got 8.24 grams of nitrogen as my answer, which I will highlight. Whoopsies. It's a long process. Do you have any questions about what you've seen and where any of the numbers came from? If we were like together for realsies, I would make you memorize the whole thing. But since we're not, what I want to do is show you in a very explicit way exactly what I did and give you a little template you can use for these kinds of problems. You can thank me later in the chat. You can send me a present. But if we were together in like real people times, I wouldn't show you this. I'd make you figure it out on your own. But here we go. This is the most important part if you have been paying attention so far. And the second to last thing we'll do, here's how all of them set up, okay? I'm gonna write it out first, and I'm gonna tell you where everything comes from. And then I'm gonna ask you to do that problem above. So here's what it looks like. You're given some grams of A in these problems. Again, each one of these looks exactly the same. You get 1 mole of A over the molar mass. Second step is the mole ratio step. Moles of B over moles of A. And the last step, you have 1 mole of B on bottom and the molar mass. That's not how you do it. Molar mass of B on top. Take a second. I'm going to show you where all of these come from. And then I'm going to color code the whole thing in like a real master stroke, where you'll be like, wow, this teacher really does get it. This one, that comes from the problem. So you have to read that. Sometimes you have to read it 10 times. These two are the same. Molar mass and molar mass. They come from the periodic table. Moles of B and moles of A. That comes from the balanced reaction. And finally, running out of good colors. Finally, that one and those are literally the number one. Look at that color coding. You impressed? I told you I was going to do a good job today. Take a second, take a picture if you're like lazy. I don't know who like is just sleeping in bed right now. You think you'll figure this out eventually? I'll get you, don't worry. When I get you with a video quiz, you'll have no idea. But if you're too lazy to write it, or if you're not having enough time to write it, or if you are taking notes elsewhere and you want to just come back to it later, take a picture of it. Take a screenshot. And then you can use it. You can use it whenever you need it. But my hope is that eventually you'll memorize it. You'll know. Any questions about the setup, the color coding? Pastel color scheme, very impressive. Does anyone want my Venmo to transfer money to me because of the success of this? Questions? No? Okay, so then what I'm going to ask you to do is right above this to try this problem. See how far you can get with it, whether you're just setting it up or doing the whole thing. If you're a calculator person and you've got it, which I would encourage you to do at this point, using this setup, can you, and your periodic table and a calculator, can you set up this problem and then answer it? The question says, how many grams of hydrogen will react with 40 grams of nitrogen? Again, if you're sticking with my cake analogy, then this one is you're like you have 40 eggs. How much sugar do you need? Okay, so you're only talking about these two reactants. Give it a try. Converting nitrogen into hydrogen. Give you a minute. Right, let's go. Here we go. What you're given first is 40 grams. That's not, let's do better, Mr. Summers. 40 grams of nitrogen, that's, okay. This is off to a bad start. 40 grams of nitrogen, N2. I'll go faster because I think we know what we're doing now. 40 grams of nitrogen, the first step is to convert grams of A into moles of A. Use the periodic table. We already did this in the last problem. The molar mass of nitrogen is 28 grams of nitrogen per mole of nitrogen. Again, that came from the periodic table. I added the molar mass of 2 nitrogens. Next is to use the mole ratio. So I'm starting at nitrogen and I'm going to hydrogen. Starting at nitrogen. Oh, let's get rid of this. Starting at nitrogen and I'm going to hydrogen. So it's a 1-to-3 ratio, as you can see from the balanced reaction. So I already forgot. 1 nitrogen gives you 3 hydrogen. 1 mole of nitrogen gives you 3 moles, or reacts with 3 moles of hydrogen. And then finally, I want my answer in grams of hydrogen, so I use the molar mass of hydrogen. The molar mass of hydrogen is 1 plus 1, so you're saying 2 grams of H2 equals 1 mole of H2. Don't get fooled there. That's a bad way to do that. You have to add up 2 hydrogens, not just one of them, and then each hydrogen is worth 1, as you can see right there. Okay, and then mathematically, again, this is the fun part. You take 40 times 1 times 3 times 2, divide by 28, divide by 1, divide by 1. Of course, you can leave the ones out, and then you hit enter on your calculator, and if you do that, you get a number that I definitely forgot, 8.57 grams of hydrogen, 8.57 grams of hydrogen. Show your hands in the chat or on the screen or emoji, pick your favorite and tell me if you got that one right or you were getting there. Oof. Only, okay, there are some hands. Thank you. Does anyone have any questions about these? My goodness.